Hello students, I hope you are doing beautiful mathematics. In this video, we will learn about how to detect right angles in cyclic quadrilaterals. This is a beautiful part of Math Olympiad geometry. This problem came up in American math competition, but it is also useful for IOQM, ISI-CMI entrances and similar contests. You can check the link in the description to find out more resources related to this. Let me describe first what the problem is. I will also give you a challenge question. Make sure to do this while you are watching this video. The problem says that you have a circle and you have a quadrilateral inscribed in the circle. A, B, C, D. And what we want to do is we want to find out the area of this yellow region. The side lengths are given 7, 24, 15 and 20. And working on hundreds of problems like this in the past 15 years have taught me that whenever I see triangles or quadrilaterals like this with numbers given, I should look out for Pythagorean triples. Pythagorean triples are like this. A, B, C is called a Pythagorean triple if A square plus B square is equal to C square. If that is there, then a lot of things simplify. So here is a pro tip, if you say so. Always look out for Pythagorean triples or hidden Pythagorean triples. So here you see, we immediately recognize that 7 square plus 24 square, which is 625, that's also equal to 15 square plus 20 square. So turns out that if I draw this line and if it passes through the center, remember AC need not pass through the center, but if it passes through the center, then this angle becomes 90 degree and this becomes a right angle triangle and this becomes a right angle triangle and this becomes 25. That's the ideal scenario. We don't know whether AC will pass through the center. That is something that we have to rigorously prove. So we will use the property of a cyclic quadrilateral that B plus D is 180 degree. Sum of the opposite angles of a cyclic quadrilateral is 180 degree. So this is, let's do one thing. Let's draw this line and suppose it doesn't pass through the center, AC. Then we can use the cosine rule in both of these triangles, ABC and ADC. So the cosine rule says that 7 square plus 24 square minus 2 times 7 times 24 times cosine B is AC square. But that's also equal to 15 square plus 20 square minus 2 times 15 times 20 times cosine D. Okay, so that's great. First thing first, since B is equal to 180 minus D, therefore cos B is equal to cos of 180 minus D is equal to minus cos D. So if cos B is equals to cos D is T, then this is minus T. Cos B is minus T. So we can replace that. So 7 square plus 24 square minus 2 times 7 times 24 times minus T is equal to 15 square plus 20 square minus 2 times 15 times 20 times T. Now comes the real calculation part. This is 625 and this is also 625. That was the initial observation. They cancel off. So we have minus minus is plus, so 27 times 2 times 7 times 24t is equal to minus 2 times 15 times 20 times t. Herein comes the conceptual part. If t is not equal to 0, then we can cancel off t. If t is not equal to 0. But then, if we cancel off t, we get something positive equal to something negative. How can something positive be equal to something negative? It can't be, right? So, we cannot cancel off t. We cannot cancel off t. Because then we get a contradiction. So, t must be equal to 0, which means cosine b must be equal to 0 or b must be equal to 90 degrees. That's it. We found the fact that angle b is 90 degrees, so angle d is also 90 degrees. Therefore, this is an angle in the semicircle. Therefore, AC must pass through the center point, and it's 25. And you can now calculate the area of the entire circle, and you can calculate the area of this triangle and this triangle. So this is simply half of 7 times 24. This is half of 15 times 20. So you can add them up and subtract it from the circle's area, which you know because you know the diameter is 25. Can you give me the final answer in the chat, in the comment section? I hope you enjoyed this video and you learned something from it, especially how to use cosine rule to detect right angles in a quadrilateral. Thank you for watching this video. Check the link for more resources and I'll see you in the next one.